simple and compound interest. So money, this has to do with money. So hopefully that lets you know how it's important and why it's important. So interest is the amount of money paid or earned Interest is the amount of money paid or earned for the use of money by a bank or other financial institution. So the reason when you put money in a savings account, the bank pays you interest is because they're actually able to use your money to then loan other people money who are paying an even higher interest rate to them. So we might get 2% interest while they're charging 6, 7, 8, 10% on someone who's borrowing the money. So that's how the bank makes money. They loan money at a higher percent interest than they give to those who put money in the bank. So here's the first equation we'll use. I equals PRT. I is the interest that's earned. P it stands for the principal. And this is not the principal like the administrator over a school. The principal is the amount of money initially invested or borrowed. And then the annual interest rate is R, and while that is a percent, we'll always put it in as a decimal. So 6%, we put in 0.06. And then T for time, and that'll always be in years for our purposes. This can work for other types, but we're just sticking with annual stuff. Now, simple interest is paid only on the initial principal of a savings account or loan. So if you put in $100, they are giving you interest on just $100. So let's find the simple interest rate to the nearest cent. So we're looking for I, so I'll write I. Then I do P, which is the principal, $1,000. The interest rate is 4.5%, so I have to change that to a decimal, which would be 0.045, and it's going to be earned for 2 years. So you simply multiply those together in your calculator, 1,000 times 0.045 times 2, and we get $90. So by investing $1,000 in a bank at this interest rate, you could leave that in for 2 years, and not only would you still have $1,000, but you'd have earned $90 on top of that. Now let's look at what if we invested $2,500 at 6.75%, so 0.0675, and times 3 for 3 years. So this is a higher amount of money we put in, a higher interest rate, and a longer time. So this should lead to even more interest than the first one. 2,500 times 0.0675 times 3 gives us $506.25. And you didn't have to do anything but just put money in the bank and leave it, and you earn that much. Okay, now let's talk about it on the borrowing aspect. Let's say Mrs. Robinson borrowed $1,860 to buy a computer. She'll pay $71.30 per month for 30 months. Find the simple interest rate for her loan. Okay, so we do have a little bit more work to do here. We're looking for the interest rate. So we've got some pieces we need to find. Now, the principal, we know, it's $1,860. The interest rate is what we're trying to find. We know the time, but they gave it to us in months, so we need to convert that to years. So to do that, there's 12 months in a year, so do 30 divided by 12, and you get 2.5. So that means the time is 2.5 years. So I'm going to pause. I'm afraid I'm going a little bit too fast. We're still dealing with the same equation that was introduced up here. I equals PRT. So this time, they're wanting us to find the interest rate. So it's R we're trying to find, not I, the amount of interest earned. So they told us the principal, we're trying to find the R. We were able to find the time by converting it from months to years. Now, I had to think, how is this useful to us? Well, to figure out how much interest she's paying, we'll need to compare how much she paid in total versus how much she borrowed. So think about it this way. If we multiply $71.30 times 30, we get $2,139. So she borrowed $1,860, but because it was a loan that charged her interest, she ended up paying back more than that amount. So if we subtract 2139 minus 1860, that will tell us how much interest she paid. Because obviously she had to pay back the 1,860 she borrowed, but then on top of that she also had to pay some interest. So we get I equals $279. So she paid $279 in interest. She borrowed $1,860 and did it for a length of 2.5 years. So now we have all the pieces we need to solve for R. So we plug in 279 for I, plug in 1860 for P. We don't know R, but we know the time is 2.5 years. So if you need to pause or rewind to make sure you follow how we got all those pieces, that'd be a good idea if you need to, because this one is obviously less direct than these two were. So now to solve for R, I would start by multiplying 1860 by 2.5. That gives me 4,650. Okay, so I just combined the 1860 and the 2.5. Now, this is 4,650 times R, so to move that out of the way, I need to divide both sides by 4,650. 279 divided by 4,650 turns out to be exactly 0.06, so that means she paid a 6% interest rate. Okay, that's simple interest. Compound interest works a little bit differently. Compound interest is paid on the principal and the interest earned along the way. So here's what that means. Just to illustrate, let's say you put $100 in the bank and you had 5% interest and you did it for 2 years. So with a simple compound interest, you'd get 5%, which is $5 the first year, another 5%, another $5 the second year, because both times they're just looking at how much you put in originally. So you'd earn a total of $110. Well, your principal plus the $10 of interest with simple interest. But when we do compound interest, they will give you that 5%. So you start with $100. Then you'll get $5 at the end of the year. And then they'll actually give you 5% not on the original 100, but for the second year they'll give you 5% on the 105. So instead of just getting $5 the second year, you'll get you'll get $5.25, which gives you a total of $110.25. Now I realize at this rate it's just a quarter difference, which isn't huge. But the point I do want to make is compound interest allows you to earn more interest more quickly, because not only are you earning interest just on what you put in originally, but then once they add interest to your account, they then give you interest on that amount also. Okay? So with simple interest, our goal was to find out how much interest was earned. We didn't say what's the total amount in the account. We just said how much interest was earned. But with compound interest, our goal is to find the total amount of money in the account after interest is earned. So A is the amount in the account at the end. Principal, now they use an uppercase instead of a lowercase. I don't know why they changed that, but it's still the principal. R is still the interest rate as a decimal. T is still the time in years. So things are structured a little bit differently, but we still have a P, R, and T, just like we did in the simple interest. Okay, so I'll show you this in just a moment. But let's actually set it up in number 3, then we'll apply this. Okay, so what is the initial amount of money in account where $600 is invested at, sorry, I think I have a typo here. I don't think I need the word initial. It should just say, what is the amount of money in an account where 600 is invested, so that's the principal, at an interest rate, R, of 8.75%, so I do 1 plus 0.0875, compounded annually for 2 years. So we put a 2 right up there for 2 years. Okay. So sorry about that typo. Let's just say, what is the amount of money in account at the end of 2 years? When they put in 600, they got a great interest rate at 8.75%, and it went for 2 years. So here's where this information is going to be helpful in your calculator. Now, the calculator I'm using is not identical to yours. And I'm not sure it's actually going to be visible. Oh, there's kind of visible. Okay. I'll just say in your calculator, just follow these examples exactly. So we're going to do what's in parentheses first. 1 plus 0.0875, which is just 1.0875. Then hit enter, so it goes and calculates that, which I did. Then you have a button, it's near your squared button, but it says X to the Y. And you can just hit squared on this one, but there may be times you're doing 7 years or 5 years, and so the squared button wouldn't work. So this is allowing you to put in whatever exponent you want. So you'll hit the XY button, and then type in 2, because that's the number of years. Press enter, and you should be at like 1.1826. So I'll go ahead and write that down. So we took care of this. This ended up 1.18265,625, and so on. Then you multiply that by the principal, by 600. And we'll round to the nearest penny. So that turns out to be $709.59. Now, you can figure out how much interest that is, because we could just subtract 600 from that, and that would tell us that they earned $109.59 on that account. Okay, last example. What is the total amount of money in an account? Yeah, maybe that's the word I wanted up here. Total. What's the total amount of money in an account where $5,000 is invested? So that's our principal. At an interest rate, that's our R. Compounded annually after 48 months. So like one on the front, they gave it to us in months, so we do have to convert that to years. So we need to divide that by 12 and see that the time is 4 years. So now let's plug it into the formula we have up top. A equals, P is 5,000. Then I put a parenthesis and put 1 plus. I change the interest rate to a decimal, 0.05. And the T, the time, is 4 years. So following the advice we have up here, we do 1 plus R, so 1 plus 0.05. Make that, I don't think I can, hold on. Adjust this and you can see both. Whoa. Need to tighten that up. Give me just a second. Has not been giving me the trouble before. Well, I'm sorry, the camera is malfunctioning, so I'll just leave it so you can see. this part. So we start by hitting 1 plus 0.05, which is 1.05. So hit enter or equals. Then use the X to the Y button to raise it to the 4th power. And you end up, I've never had this happen before. I don't know if I can hold it while I'm doing this or not. I'm going to try. 1.05 raised to the 4th is 1.2155. Then we multiply that by 5,000. And we get $6,077.53. So that's the total in the account after that interest is earned for 4 years.